Hey Algebra 1, in today's video we're going to go through a couple practice problems starting on page 303 in your binder, so if you could find that page. That'd be great. You don't want to take these notes on your own sheet of paper, make sure you find the binder page 303. And so what we're going to do here is talk about something called a linear inequality in two variables. So we've done inequalities with one variable, like x is greater than 7. But now what if we have a problem where there's an x and a y? So that's what we see here in example 1. Okay, graph y is greater than 2/3 x minus 1. So instead of graphing on a number line, we have to graph on an xy coordinate plane. And so we can see these steps here. The first step, convert to slope-intercept, we've already got that here. So we're going to remind ourselves that for this equation, the slope is 2/3, which means up to right 3. And the y-intercept gives me, or the b-value gives me a y-intercept of -1. Okay, so then there's two types of ways. The main difference for graphing this is that we might use a solid line, we might use something new called a dashed line, and we do that based on whether this inequality says it could be or equal to. So if it's a solid line, if it's or equal to, like less than or equal to, greater than or equal to, then that means the points on the lines are going to be solutions, so we use a solid line. If it's just less than or just greater than, strictly, then we say a dash, then we use a dashed line to represent that the points on the line are not solutions. So that's what we're going to do first here. So we're going to graph this line. I'm going to start at a y-intercept of -1. And then I'm going to do my slope of up to right 3. Up to right 3. I could go back and go down to left 3. And you can see the shape of my line, but now instead of drawing a solid line through it, I'm going to draw a dashed line, like this. Okay, and you want to make it real big here. Cover up the whole coordinate grid. Because what we're saying is that there are x and y points that make this inequality true, and those points that make it true are either going to be above the line where I'm indicating now or below the line, and our job is now going to be to figure out which of those sides is the correct side. So one thing I like to do is to actually kind of give myself a label here of the two sides of the line. I have this side up here above the line. I'm going to call this side 1, and I'm going to call this side below the line side 2. Right? The line divides it into two sides, 1 and 2. So now I've got to figure out which of those sides is the correct side to shade, and we shade to indicate which points are solutions, which points make the inequality true. All right. So the way we figure this out is we do a test point. Okay, we're going to test a point. I'm going to test 0, 0. Most of the time, you can test the point 0, 0. Because it's going to be on one side of the line or the other. As long as 0, 0 doesn't go through the line, the line doesn't go through 0, 0, you can test that point. Okay, and how do we test it? We plug it in. So I'm going to go plug 0 in for x and y in that equation, or in that inequality. So it's 0 is greater than 2/3 times 0 minus 1. And then you do the math. 2/3 times 0 is 0, so it's 0 is greater than -1. This is true. 0 is a bigger number than -1. And so a true inequality, we can see this flowchart here, the point is a solution, so we shade the side containing that point. Well, out of 1 and 2, which side contains the point 0, 0? It's side 1. So what that means is 0, 0 was true, and any other point that we picked on this side of the line would be true. So now what we do is we shade that side of the line. So the way it will probably look when you do it is you can shade it in different ways. I like to kind of just go like this. Okay, you don't have to perfectly get everything, but you want to indicate that that side is shaded compared to the other side. The other thing you can do is cross off the side, like, so I'll cross off 2 and say, hey, that's not the right answer. It's not that side. You don't have to do that. A little later on we might, though. Notice if it's false, we got a true statement. If it had been false, that meant we guessed wrong. That point would not have been a solution, so we would have shaded the other side. All right, all the points, so we could pick any point in this section here, and it would make the inequality true. So then, example 2, list 3 solutions to each inequality. Well, the solutions are points that are shaded. Now, if you can't tell on your copy here, the shading for this problem here is there, and for this problem here is there. You might have to fill that in on your copy. Okay, so list 3 solutions. I can pick any point in that red shaded area. So maybe I could pick the point 2, 1. I could pick the point -3, or so that's a -5, -5, -2. I could pick the point 1, -4. I cannot pick any point on the line because it's a dashed line. Okay, now here on B, I could pick maybe -2, 5, or I could pick -6, -3. Or, because it's a solid line, I could pick any point on the line. -3, 0 is a solution also. So when it says how many solutions are there to linear inequalities, well, how many points could I have picked? Well, an infinite number of points, right? All those points that are shaded, but really even that shading continues on forever and ever outside the coordinate grid too, right? It's any value that's above that dotted line, any point. So there are an infinite number of solutions. So instead of writing them out, that's why we do the shading, to represent those infinite solutions. All right, flip the page. So for example 3 here, we're going to determine if it's a solution to the inequality. And we do the same thing as our test point, we just plug in. So we know that in this coordinate, this 0 is x, this 0 is y. So I'm going to plug in 0 for x and 0 for y. 0 minus 3 times 0, is that less than or equal to 6? Well, this would be 0 less than or equal to 6. That's true. So we get a smiley face, so we would say yes. 0, 0 is a solution. Okay, for B, 4, 1, again, mark it, x, y. So I'm going to plug in 1 for y greater than 2 times 4 minus 5. That says 1 is greater than 8 minus 5, 1 is greater than 3. Wait, is 1 greater than 3? Go back to your 3rd grade days. Is the alligator eating the correct number? No, right? 1 is not bigger than 3, so this is sad face. And we would say no. So let's finish off with just a couple more examples here real quick. Example 4, problem A. Graph each linear inequality. So you have 2 decisions to make. You've got to figure out, is it going to be a solid line or dashed? So solid or dashed? Well, we look at the symbol here, and that means we should do solid, because it's or equal to. And since it's or equal to, we do solid. Okay, my slope is 1/2. My y-intercept is 0, -4. So let's graph this line. Go down to -4 for my y-intercept. Up 1, right 2, down 1, back 2. We know it's supposed to be a solid line, so I can draw it in like that. Okay. And then, again, if you want, you can label your sides. I've divided the graph into a top part and a bottom part. So let's see which is the correct part to shade, above it or below. So now, this is where I do my test point. I'm gonna test, and I look, is 0, 0? Let's do that, we'll put a question mark. Is 0, 0 on the line? No, so I can use it. 0, 0, and then I plug it in. 0 less than or equal to 1/2 times 0 minus 4. 0 less than or equal to -4. Is 0 smaller than -4? No. So that means that was the wrong side. I take my question mark, I cross it off. That was wrong. I have to jump to the other side of the line, and I shade down there. Those points are the ones that are solutions. So we're going to stop there. Thanks for watching. We'll practice this more in class. Have a good one.